Hello students, good morning. My name is Dr. Mallikarjun, working in Institute of Aeronautical Engineering in the Department of Information Technology. In the series of video lectures operating systems, today I am going to discuss about the longest remaining time first scheduling algorithm. It is a preemptive scheduling algorithm. It is works in the principle of preemptive principle in the operating system. To manage the execution of process, prioritize the process with the longest remaining burst time, meaning that process needs to most time to complete execution will be run fast. This algorithm is a preemptive version. So longest job fast algorithm preemptive version is longest remaining time first algorithm. So in previous lecture we seen the longest job first algorithm. That same video lecture is continuation with this lecture, longest remaining time first scheduling algorithm. So longest time is executing fast. This is the principle of the longest remaining time first algorithm. See, longest remaining time first algorithm is a completely different than all other algorithms like first come first serve, shortest job first, longest job first also. So it is this first come first serve is a non-preemptive algorithms. Shortest job first is also a non-preemptive algorithms. First come first serve and shortest job first, those are non-preemptive algorithms. Meaning once process starts, it cannot be stopped. Voluntarily relinquish the CPU. CPU is relieved. Then next process is going to submit and execute in the CPU. That is the performance of the CPU. But longest remaining time fast, the process in the order they arrive without considering priority of the factors. See, preemptive scheduling process means once process submitted, it executes some time, then it can switch to other process. Context switchings are more in the preemptive scheduling algorithm. So, longest remaining time fast algorithm is absolutely a preemptive scheduling algorithm. So, this is a preemptive scheduling process. See, non-preemptive is first come first serve scheduling algorithm, shortest job first algorithms. In last video, I discussed the longest job first algorithm also is a non-preemptive scheduling algorithms. Means once process submit to CPU, it executing complete the burst time and then it can give the chance for the next process in the execution. It voluntarily relieved that process and give the next process in the execution. That is a non-preemptive nature. So, coming to longest remaining time for scheduling algorithm, we will see one example problem. Okay, students, this is the problem. There are 4 processes. So, process P1, process P2, process P3, process P4. Their arrival times are 1, 2, 3, 4. Their burst times are 2, 4, 6, 8. Now here longest remaining time fast, they given the time quantum is 1 unit of time to execute the process. Every process is execute 1 unit of time only. That is the time quantum. So it is a preemptive scheduling algorithm. So it is preemptive scheduling algorithm. So we worked out this problem, how this problem can work under the criteria of longest remaining time first algorithm. See, first draw the Gantt chart. See, at 0th interval of time, no process is executing in the CPU. No, but arrival time there is no 0. So no process could not come enter into CPU. So that is nothing, nil. So now arrival time is 1. So process P1 comes and execute the CPU. P1. But their time quantum is 1 unit of time only. So up to 1 unit of time, P1 is executing. Now our bus time, now time is, the bus time is only 1 unit of time. 1 unit of time only executing, remaining 1 unit of time is left. Now arrival time is 2 units of time. So which process come eligible to execute in CPU? 2, arrival time 2. P2 is only having the chance to execute in the CPU. So P2 comes and execute at 1 unit of time. So at 3 units of time. Okay. Now remaining 3 units of time is left. Now arrival time is 3. Now arrival time 3. Only P3 have the chance to execute at 1 unit of time. So up to 4 units of time. Now P3 having the remaining time as 5 units of time is left. Now P4 got the chance at arrival time 4. P4 got the chance and execute 1 unit of time. Now at 5 units of time P4 is executing. Now remaining time is left is 7 units of time is left for P4 process. At 5 units of time, now 5 units of time, all processes are ready in the executing into the CPU. P1, P2, P3, P4, all got the chance in the CPU for the execution. So now the algorithm is applicable here. Longest remaining time first. So among P1, P2, P3, P4, which having the longest time for the execution? P4 is the 7 units of time. So got the chance for P4 for the execution. So P4 execution and 1 unit of time, 6. So remaining 6 is the left. So again got the chance P4. Longest time is P4 and execute 1 unit of time at 7. So remaining 5 units of time is left. Now again P3, P4 having longest time. P3, P4. Both are 5. So which is the got chance to execute fast? First got the chance P3. P3 execute 1 unit of time, 8. So P3 got the chance. Remaining 4 units of time is left. Next P4 got the chance to execute. So P4, 4 is the left. 9. Again P3, P4, 10, 11, 3, 3. Now P2, P3, P4 got 3 units of time. So which one got the chance first execute? P2 got the chance first execute. Then P3 got the chance next execute. Then P4 got the chance to execute. So 13, 14, 15. So the remaining time left 2 units of time, 2 units of time, 2 units of time is left. Again got the chance P2, P3, P4 got the chance to execute. So 16, 17 and 18. So there first time 1 unit of time, 1 unit of time, 1 unit of time. Now got the chance to execute P1, P2, P3, P4 got the chance to execute. So there remain arrival times left 0, 0, 0, 0. So 18, 19, 20, 21, 22. Now arrival time took to 22. All process completed in the execution. So this is the way executing the longest remaining time first scheduling algorithm. Now we calculating the completion time. Now we calculate the completion time where P1 is completed at 19 units of time. P1 is completed. P2 completed 20 units of time. P3 completed at 21 units of time. P4 completed at 22 units of time. Now turnaround time. Completion time minus arrival time is the turnaround time. So completion time minus arrival time 19 minus 1 18, 20 minus 2 18, 21 minus 3 so 17, 18, 21 minus 3 18, 22 minus 4, 22 minus 4 18. Waiting time, turnaround time minus bus time. So 18 minus 2, that is 16. 18 minus 4, that is 14. So P3, P3, 18 minus 6, 18 minus 6, 12. P4, 18 minus 8, 10. Now response time. Response time for P1. Response time for P1. P1 when it arrived, P1 18. So P1 is arrived at 18. Then arrival time is 1. So 18 minus 1. Their arrival time is 17 for P1. Their response time is 17. P2 arrived at 19 units of time. They arrived at 19. 19 minus 2. 17 is the response time for P2. P3 arrived at 20. They actually arrived at 3. 20 minus 3, 17 is the response time for P3. P4 arrival time 21. They arrived at 4. So 21 minus 4, that is also 17. So we got all response times are same, 17, 17, 17. We got all turnaround times are same, 18, 18, 18. See, the problem having beautiness, this problem we seen that. We got same values of the response time. We got same values of the turnaround time. So this is where the problem works under the longest remaining time first scheduling algorithm. So we got the problem and we got the result, the process, how they are executing a long time. So as per the problem, the remaining time first, because longest process having more number of context switching between the P3 and P4. So if response time is increasing, if time quantum is decreasing, so response times are increasing, and also waiting time is decreasing. We've seen this problem in the last video also. So this problem is completely works for the longest remaining time first algorithm. The response time we've seen the delay before the process received first in the CPU. So when the process arrived in the Gantt chart, that value is subtracted that arrival time value. That gives the response time. Turnaround time is waiting time minus bus time. So that is the total time for arrival of completion. Waiting time is turnaround time minus bus time is the process spends waiting in the ready queue. Completion time, when the process completed in the Gantt chart we seen from last to first, that process when completed, that given the completion time. Burst time already given in the problem, that process needs to execute on the CPU, that is called burst time. Arrival time also given in the problem, when the process enters into the ready queue, that also given in the problem, that is the arrival time. So in this video, we've seen the longest remaining time first problem completely based on the one example. Okay, students, we collected this information from the book Abraham Silverskap's Peter Galvin book. The title of the book Operating System Principles, Wiley publisher, 8th edition 2010, and also the book William Stallings, title of the book Operating Systems Internal Design and Principles, publisher Pearson Education book. Longest remaining time for scheduling algorithm works with the preemptive scheduling algorithm. We've seen the one example of the time quantum is 1. We get the turnaround time same values and response time also same values. But longest time process executing long time, we've seen this problem with the time quantum. Okay, students, thank you. Thank you to watching this video.
Like, share and subscribe. Hit the bell icon for more updates.